Hello again, welcome back to Mr. Algebra. In this video we're going to show you how to do some of the special products we use in Algebra 1, special products of polynomials. And the two types we're going to be working with mostly are the square of a binomial and the sum and difference product. And the square of a binomial is anytime you take a binomial and times it by itself, in other words you're squaring it. And the result over here is called a perfect square trinomial. And the reason we call this a perfect square, it's just like taking any old number. Let's say we take the number 7 and times it by itself, so 7 squared, or squaring of a number, and that gives us a 49. And of course the result here is called a perfect square. So since this one's a trinomial, we call it a perfect square trinomial. But the shortcut is to just take the first number, square it, the last number, square it. That's the first and last numbers of your trinomial. And the middle number comes from multiplying the first number with the second number, or the first term with the second term, and then timesing it by 2 or doubling it. And then when we get to the examples, I'll show you why you do that, because I'll do this the long way by foiling it out or multiplying it out and then doing the shortcut. There is a possibility that your squaring of the binomial could have a minus between it or subtraction, and the only difference in the output is the first sign right here is going to be the same as what's inside the parentheses. The last terms still have a plus b squared, and the reason for that is when you square this last number, anything times itself comes out to a positive every time. So perfect square trinomials always have a plus here at the end. Perfect squares on the front and back, plus at the end, and the middle term comes from first term times the second term times 2. The sum and difference, and the only difference between these two is one is plus and one is minus. You'll notice the two terms themselves are the same, a and b. And the product of a sum and difference comes out to the first number squared, so a times itself, a squared, minus, and this is always a minus no matter what order these two signs come in, and the last term squared, b squared. There's no middle term, and that's because the middle term drops out. And this right here, this product, has a name also. It's called the difference of squares. Now these special cases serve one main purpose, and that is to multiply them out quickly, but when we get to factoring and solving quadratics, they also serve the purpose of taking this and factoring it back into this instantly, and that is if you recognize these. The sum and difference, which creates a difference of squares, is much easier to recognize than a perfect square trinomial. Okay, so for our first example here, we're going to do a square of a binomial with a plus between them, and what you'll want to remember here is that 2n plus 5 raised to the second power really means 2n plus 5 times 2n plus 5. Now I'm going to do the shortcut version over here, the special product purpose of this, and then I'm going to do the long multiplication over here, the foiling or the multiplication of that binomial. So the shortcut says to take the first term, which is 2n, square it, take the second term, which is 5, put this at the end, and square it. And then for the middle term here, we're going to take a plus because we have a plus here. So plus 2n times 5, so 2n times 5, so a times b. But there's going to be two of these, so we're going to double it. So this ends up giving us 2n times itself is going to be 4n squared. 2 times 5 is going to give us 20n, or in other words, 2 times 5 is 10, times 2 is 20. 20n, and then I forgot my plus sign here, and then 5 times 5 is going to give you a positive 25. So you don't have to necessarily show this. You can go from here directly to here if you know that pattern. Over here we'll go ahead and multiply it the traditional way. 2n times 2n is 4n squared, and then 2n times 5 is plus 10n, and then we're going to multiply here. 5 times 2 is going to give us the 10 plus the n again, and then the 5 times the 5 is going to give us a plus 25. And you can see we have two numbers in the middle that are exactly the same, and that's why we end up multiplying by 2 here, because 2 times 5 gives us the 10, but there are actually two of them when you square a binomial. So to simplify this, we get 4n squared. This makes 20, so plus 20n plus 25. Okay, so it doesn't look like a whole lot more work here, but once you learn this pattern here, this over here saves you a lot of time. Here's another one with a minus in it, and the only difference between the plus and the minus is this first number right here will end up being a minus. So we're going to take this first one right here, square it, and that's going to give us 4n squared. We're going to take this last one here and square it, and that's going to give us a plus 25, and that's expected because those are the same two numbers we had up here. Then we're going to do 2n times negative 5, which is negative 10n, and then double it, so times 2, and that gives us a negative 20n. And you'll see that this right here looks just like this one up here, only difference is this one had a plus because that was a plus, and this one has a minus because that one was a minus. And that's our shortcut to squaring binomials, so we don't have to FOIL or multiply vertically. Our next example brings in two variables. So we're going to take the first one, which is 3x, square it, and that's going to give us 9x squared. Leave some space, square the last one. So 8y squared is going to give us a positive 64y squared. And then for this middle term, which is going to be a plus, and the reason we know it's a plus is because we got a plus here, is to do 3 times 8, which is 24. X times y is going to give us xy, and then all you got to do is double it because there's going to be two of them, and that's going to give us 48xy. So if I were to FOIL or multiply this out, this is what I would get. Our second special product pattern is a sum and difference pattern, and that's when we have two binomials and the only change in them is one is plus and one is minus. And the shortcut is to take the first number, which is 3x, square it, bring a subtraction over, and it doesn't matter what order these come in, then take the second number, square it, and that would be your answer. So that would be 9x squared minus 4, and that's what you get. If we FOIL this out, we'll see that the middle term does drop out. So 3x times 3x is 9x squared. 3x times negative 2 is negative 6x, and then 2 times 3 is a positive 6x, and then 2 times negative 2 is a negative 4, and you'll notice that these middle terms right here are the same, so they cancel each other out, leaving 9x squared minus 4, which is what we got right here. Our next example of sum and difference is our final example. We have two variables in there. One is minus, one is plus. Notice the order of the add and subtract is different, but that doesn't change the answer. All we got to do is take the first number, which is 2a, square it, bring a minus sign, this is always minus. Take the second number, which is 5b, square it, and our final result is going to be 4a squared minus 25b squared, and that's our answer.